biological pest control, which is all about beating the bugs, the slugs and the grubs. I'm speaking on the basis of our own experience at Fletching Glasshouses, where we grow organic vegetables. We also grow pot plants for gifts as well, but the main place where we use the biological controls is in the glasshouses. So if you think about it, all the energy on the planet comes from the sun, and we just can't use that energy unless we have plants to turn it into food. But of course there are other creatures on this earth who also can't use energy unless they eat plants. So it's not really surprising that there are other creatures that when we provide, when we grow plants for our enjoyment or whether we grow plants for our food, when we put them out, other creatures come along and eat them. It's just not surprising. We shouldn't really maybe think of them as much as pests as competitors. It's part of the natural world. So that's just a bit of philosophy, and now let's move on to how we control the pests and how we stop them using up all our plants before we've enjoyed them. So there are 4 definite types of control for pests. The first one is chemical control. Chemical control means using a chemical and artificial substance to poison the pest, and the downside of that it can get right into the plant, go right through the ecosystem and have surprising results on other creatures. The second, we don't use that at Fletching Glasshouses because we're organically certified, so we only use biological controls. If we want to kill insects with a pesticide, we use a biological pesticide, something like soap, which has a physical action and it doesn't get into the plant and spread through the ecosystem. The second method is cultural control, which is a really useful way of controlling pests, and that is just to find out what they like and try and avoid it. So straightforward example is we get tomato blight every year at our glasshouses, and we try and avoid it by growing early tomatoes, bush tomatoes, so that we escape that little window. And there are all sorts of other examples of just getting around the situation. The third method is physical control, and that would mean like putting nets over carrots to avoid carrot fly, and it would involve putting up sticky traps to catch insects and all those physical methods. But the one we're going to talk about this morning is biological control, and that means finding the natural enemies of these pests and introducing them, and they can do the work. And I've got 5 examples that I want to go through this morning. I'm going to talk about nematodes, mites, parasitic wasps, mealybug predators, and then lacewings and ladybirds. So let's start off with the first example, which is nematodes. Now, nematodes are actually one of the most abundant creatures in the soil, and there are all sorts of different nematodes. They're part of the whole soil life, and the soil wouldn't be alive without them. They're essential. But there are good nematodes and there are bad nematodes, so people find that confusing. So the sort of nematodes that eat your potatoes are sort of like the bad nematodes, and the sort of nematodes that eat the slugs are the good nematodes. It's just a question of whether they're on your side or not. And nematodes are bred in this country and packaged out. You can buy them as a little paste. Different nematodes attack different creatures. So you can see examples there. There's chafer bug and leather jackets which attack your lawns. There are nematodes for those. Then there are nematodes for slugs. There are nematodes for vine weevil. And then there's mixes of nematodes for caterpillars and so on. So there's all sorts of different ones. It's not just you buy a pack of nematodes, you have to know which one you want. Now when they come, they're alive. So on the next slide is an example where I put the nematode paste that we'd just bought under a microscope, and if you look really carefully, you can see that they're moving. So that's what they look like at 1 to 200, and that's just putting a microscope on that paste that you see being passed around. And how do they work? Well, they seek out their prey in the soil by detecting the waste matter from their prey, the slug trails and whatever. And when they find their prey, the slug, for example, then they get inside it through their ears or all sorts of other holes in their body, and then they dissolve the slug from the inside, and then they use the dissolved parts as a nursery to breed more nematodes and so on. So that's how they work. And on the left you can see the slug has got a great big swelling, which shows it's been infected. It actually, interesting enough, it's not the nematodes actually bring bacteria in to the slug to dissolve it from the inside. So there's another living organism involved in the whole process. So once you introduce them, they'll carry on reproducing, and they'll carry on until they run out of slugs or they don't like the conditions, and then they'll die out again, and then you have to introduce them again. So you have to just be aware of when your plants are getting damaged, and make sure that you treat them in time. On the next slide, I think I've got an example of what happened to us when we weren't on the case. And this is our pak choi in our glasshouses, and that's what it looks like when the slugs go rampant. And that can be, in our case, it could be January and February, but if you were outside, it'd be March, April. So you've just got to be on the watch. So moving on from nematodes, I want to talk about plant mites. Now, there's a list there of mites that you might have heard of: strawberry mite, bulb mite, and so on. All sorts of different mites will attack plants. Mites are tiny, tiny little spiders, if you like to think of them like that, that have adapted themselves to live off plant cells. So they will go and suck the sap out of individual cells, and quite often the first sign you might see is a bit of stickiness around the leaf, and that means that some insect is puncturing the individual cells. And you might be lucky, though, not to have encountered mites. So here I've got an example of strawberry mite, and on the previous slide you saw them with that when they were just starting to attack, and this is what happens when they go rampant. 2 points here. One is that the first sign, before you get to the cobwebs stage, the first sign of spider mite is actually the unique pattern they leave on the leaves by puncturing the individual cells. And that pattern is different on beans or aubergines, and you soon, when you know your own plants, if you see it on the weeds, say, you'll know, it's coming, spider mite is coming. Funny enough, spider mite is called red spider mite when it doesn't look like a red spider and it's hardly ever red, so it's quite a confusing name, and preferably we call it the two-spotted mite because over the course of the season it slowly creates 2 black spots. This is the at 1 to 400, a video I took of a young spider mite. And you can see him or her. They tend to change sex, but quite a lot of them are females apparently. And then later on in the season, you can see that they accumulate waste either side of their bodies, so they are then much more easily identified as the two-spotted mite or glasshouse mite. They move quite fast, and you can identify them under the microscope by the way that they move. And when I've got another video later of the predator, and you can see it moves in a different way. So here he is looking for something to eat, or maybe he's just scared of the microscope, I'm not sure. And then finally, here's an older one. And these are just amateur videos, so you'll see it sort of whizzing out the side and coming back in. It was the best I could do. Okay, and so we tackle spider mites with these predators here. This is going back to 1 to 200 again, and this is a video of how the predator arrives. And you can see that the predator moves in a completely different way, and he looks completely different. It's like comparing I don't know, a lion with a goat, they move in different ways because one's a carnivore and the other one's a herbivore. And so it's the same. You can see these predators are easily distinguished from the spider mite by the way that they move. And you buy them in a little tube and then let them out, and one set of mites has a war with the others, and it's a question of who breeds the fastest as to who wins. So they're widely used commercially, and that mite is called Phytocelius persimilis. But there are other mites, and you can buy mites in sachets. Al, can you just... So you can buy mites in sachets and just hang them up, and then they'll crawl out the hole at the back and eat the spider mite that way. That's a good preventative measure. But we've now got a slide on to do with something different, which is whitefly. You can see the female whitefly at 1 to 200 moving around and laying eggs. And the one thing that you can distinguish whitefly by is that when you turn over a cabbage leaf or anything, you see little horseshoes of white, and under the microscope you can see those are eggs. The other way you recognise whitefly is that when you touch the leaf of your cabbage or whatever it is, the little white things that look like miniature moths fly around. A lot of people get muddled up between whitefly and aphids because aphid skins are white and they think that they've got whitefly when they've got aphids, but in fact the best way of distinguishing whitefly is just touch the leaf, and if you get clouds of little white, then that's whitefly. It's not only us in our glasshouses that get them, you can get them outside as well. And the way to attack those commercially is with a parasitic wasp. Now you might think, oh, I don't want any wasps near me, but it's only called a wasp because it belongs to the whole family, Hymenoptera, I think they are, of bees and wasps. Creatures that have adapted themselves to sting. They either sting to attack or sting to defend. But that's the only thing that this parasitic wasp has in common with the one that the yellow and black striped ones, which you don't like. It won't sting you, it stings the whitefly, and so parasitizes them and then breeds in that way. Encarsia Formosa is this chappie's name, and we buy him as eggs on cards. So that's on our broccoli, and you can see there's a little card and with little black up here, little black band on, and that's eggs which hatch out and fly. There's a close-up of it, and then they fly as little tiny wasps. They don't look like wasps at all, and then they attack the whitefly. And that is a very common, cheap commercial way of controlling whitefly. It doesn't work on every single whitefly I have found with the experience, but it's a really good one to start with. Oh, sorry, that's the little parasitic wasp at 1 to 200, having just got out of its egg. Now, Mealybug. So it just looks like cotton wool, but when you look at the cotton wool under the microscope again, I think that's at 1 to 200, you can see Mealybug, and I distinguish them particularly by their long tails. They're quite, that's quite a good way of distinguishing them. They're very common on pot plants, orchids, bougainvillea, jasmine, olives. They love all those things. And if you don't know, you might just think, oh, well, that's a bit of cotton wool, no problem at all. But you don't realise that underneath that they're breeding. The cotton wool is, in fact, their eggs. So to combat those, you can bring in predators which are actually going to hatch out into ladybirds, but when they're young, they kind of camouflage themselves to look a bit like Mealybug, so that they can get among them and eat them up. And this is the Australian ladybird larvae. They're bred for us in Kent by Y bugs who are on the Y College campus. And they arrive by first-class post in a little tube. You let them out on your orchids or whatever it is, and then they eat up the mealybug for you. trying to be practical, it would only be worth your while if you had a problem on some expensive plants or crops, because they are going to cost you something like, I don't know, £20 to bring them in a tube. So if you can't afford that, then just wash the plant down with hot water and soap and do it again and again until all the mealybug's gone. So finally, the final example is aphids, which I'm sure you'll have seen in different forms. There are greenfly, as we call them, on roses. There are blackfly, as we call them, on beans. And then there are aphids that you get on peppers, which are kind of peach potato aphid. And then there are aphids that you get on citrus flowers. So there are all sorts of different aphids. And here's an example of one at 1 to 200 that I captured on a leaf moving around. And aphids can be tackled commercially with parasites quite cheaply. There's one called Aphids colemanni, which is a parasite which will eliminate all the normal-sized aphids, the sort that you get on peppers and so on. But the larger aphids it won't touch. So it won't touch blackfly or greenfly. Here's just one more example of the larger of the aphids. So those ones wouldn't be targeted by the cheap remedy. And here he is close up. So this one is 1 to 400 under a microscope. And you can see the typical two tubes or breathing tubes at the bottom of his body, and that is the way that you can distinguish aphids, apart from the way that they move, which is pretty obvious when you get used to it. So they just move in a different way from mites or whitefly or anything. And just a word about ladybirds. People like the idea of introducing ladybirds because they're pretty and everybody knows that they're native, and it's a nice idea, and people sell ladybird houses and so on. You can buy them. I don't think they're terribly practical to eliminate an aphid attack, but they will be introducing more ladybirds into the wild, so they're a good thing anyway. And then moving on to lacewings. Lacewings are slightly more cost effective. They are beautiful lacy winged insects, and their larvae again will eat big aphids as well as small aphids. Again, they're not cheap, but you're doing something good introducing them into the environment, and they will have some effect on your aphid problems as long as you don't leave it too late. So that's ladybirds and lacewings. And so I always like this little rhyme. So in summary, biological controls is all about finding the natural enemies of your pests and introducing them in a safe and practical way to defend your plants. We use the term control rather than killers or anything like that, because we're trying to get the population of the pest back into balance. We're not ever expecting to eradicate everything. We're just trying to get a balance back. So you always have to accept that you might have to introduce the same predator again the next year or the next season. It's not I'm going to eradicate aphids from the face of the earth kind of situation. It's just simply get the thing back into control. Quite a lot of organic growers have a little kind of measure in their mind how much attack they will accept on their vegetables or whatever they're growing. And we reckon, once it gets beyond 5% or 10% of your leaves being spoilt or whatever it is, then we would go in and really try and hammer the pest. But a certain amount of slugs and whatever around we accept.